Every participant is requested to keep their mic mute. Lastly, a feedback form will be shared in the chat box, and do fill that out.
Thank you, Shriyanshi ma'am, for that introduction. And it's an honor to be speaking with a diverse group of people. And
Sir, your voice is not audible.
am I audible now?
Yes, sir,
Is it
you're
audible?
audible. Yes, sir.
So first of all, thank you for that brief introduction. And I would like to thank SEMS Welfare Organization for giving me an opportunity and inviting me to speak on this important topic related to entrepreneurship. And I welcome all the participants. I could see some known faces and some colleagues also in the meeting group. So without taking much time in the introduction, so I chose the topic as Introduction to New Product Development for Entrepreneurs. So I'll be the presentation may contain some content which is which may be which may have copyright of some intellectual property owners, or part of this presentation may include some research work of our group, which is either unpublished or is under review or a work in progress. So here we are discussing it only for educational purposes. This is a disclaimer from my side. So we'll be discussing introduction to new product development, steps in a design process, concurrent engineering, reverse engineering, creativity in design, rapid prototyping. I'll introduce some basics of 3D printing, and we'll discuss a sample project with the participants. I have designed this talk so as to fit a diverse group of people who are from diverse backgrounds. So if we talk about entrepreneurship, it's the much talked or much debated word. We say the individual who creates new business and takes risks and enjoys rewards, if any. Entrepreneurship conventionally was intrinsic. It was sometimes God gifted, or it was people who were into entrepreneurship were not trained to become entrepreneurs. They were so because of their maybe family background or maybe the circumstances. But now, since the job market and the changes in the global economies, now governments are also pushing people to prefer entrepreneurship in comparison to employment. And a lot of people who are, interested and who are, I would say, who are excited about this, they make this entrepreneurship their passion, and they follow their goal from their very beginning of their life. So keeping that in mind, entrepreneurship, it's a sequential process, and it involves a lot of skill sets, a lot of risks. And if we say entrepreneurship, it will start with an idea. It involves a lot of planning, execution, and then depending upon the success of the project or of the idea, this will involve growth, or maybe we end up in a failure. Failure would be primarily because of poor planning, or maybe bad implementation, or bad, I would say, utilization of resources or execution. So entrepreneurship may involve new product development. Since I am from engineering background, I will address this problem from new product development point of view. So if we sequentially see the various steps that are involved in a new product development cycle or process, every new product development starts with need. So that need needs to be analyzed, and that need needs to be found out. Or we could say, like we talk in research, that we should look for some gap. So in entrepreneurship, we should look out for that need. So that is the first step in entrepreneurship, which we call need analysis. And then the second step, which I thought should be the problem formulation. So there could be n number of needs which a customer or which your market survey team found, but ultimately that has to be given the shape of a problem, which is an art. So then when we have a problem at hand, or we have a gap found out, the next step should be to develop various concepts. And this step we call as concept hunt. So we hunt various concepts using different aids. It may be creativity, and we will discuss some steps in the coming slides. Depending upon the various concepts generated, we will do feasibility analysis, which is the next step of this process. And then we select one or two concepts, and then we do prototyping and testing before the final step, which is the final production or manufacturing. So as we see this new product development is basically when we say art to part. So you may have a design in your head, a new idea in your head, or some person may have a design or maybe a new idea, but that idea has to be transformed into a physical part, or that has to be, I would say, conceptualized and then brought a physical shape. So the whole product development cycle is basically what we sometimes call as a cradle to grave approach. So right from the beginning till the end. So the different steps which involve may involve designing, defining, brainstorming, launching, and testing. So in this process, what we do is the first step, which we talked about, was need analysis. And like while doing research or while going for a new thing at our home, we ask many questions. So similarly, we have to ask many questions about, they may be asked to the final end user, they may be asked to a team member, depending upon the type of problem or depending upon the type of idea. These questions may be asked to different people or may be analyzed. The questions may be: when and why do we use the product? What do we like about existing products, which we sometimes call as benchmarking? Why don't you like other products? So what are the required functions? Who is the product user? Where is the product going to be used? Environment in new product development is very important. I will have a slide on this. And what are the unacceptable options, behaviors of the product? What should the product satisfy? What specifications do we have or no? Are there any legal issues? Maybe some intellectual property related issues maybe there with the product that you need to study. What are the human factors to be considered? Apart from ergonomics, there may be some social or ethical issues which may be related to the new product development. And what is the expected life duration? When we talk about life duration, that actually means the product, when we ideate it till it gets, either recycled or, reused. So, this finding this need, we sometimes say latent need, as we talk in terms of latent heat in thermodynamics. Here we talk about latent need, which is actually which is hidden. So that hidden need may be in the lying somewhere. We have to find that, and for that we need this need analysis. And out of that latent need, we have to find the actual need, and this process is we call as need analysis. And in modern product development, this process is very typical, because I would say the wheel has already been invented, and the apple has already fallen. Newton has given his theories and equations. Now the product development is little bit tough, competitive, and there is no visible need in the market. So that is why authors refer to this type of need as a latent need. So if we go to the next step, which is problem formulation, let me just give an example. Any system will be treated, say, for example, as a black box. There may be some inputs, some outputs. So if we take the example of a washing machine, if your team wants to design, say, for example, a new washing machine, and based upon the need analysis, which your customers may have articulated in different forms, because when a customer talks, he does not talk in terms of technical jargon. He does not talk in terms of specifications. He gives you maybe some qualitative inputs. In fact, he will not give you quantitative data. He will talk in terms of more or less. He will talk in terms of cost saving. He will not talk in terms of dimensions. He will not talk in terms of efficiency, but he may talk in terms of cost effectiveness. He may talk in terms of ease of maintenance, ease of use. So the words which he utters, or what your marketing team receives from the end user or the lead users, what we sometimes refer to as lead customers, those inputs have to be transformed into a problem which is which is having, I would say, technical specifications, and which is really an engineering problem. So because when we deal with a real engineering problem, there should be specifications, there should be dimensions, it should be properly quantified. So when we talk, say, for example, in case of this washing machine, so the restrictions may be from need analysis, that the dimensions should not be, washing machine should not be, say, for example, more than 75 centimeter by 75 centimeter. If you know, in a particular society or in a particular locality, the dimensions of the laundry or maybe the washroom are like this, and based upon that you decided that they should not be more than these dimensions. And if you are using electricity in say, for example, in our part of the world, the electricity would be having a frequency of this, and the voltage would be this, and it should be ISI approved, then only you can sell it. The cost should not be more than, say, for example, 5,000 per piece. And it should be able to process natural and synthetic fibers, and it should be foolproof if we compare it with the other, benchmarks or the existing products. So if we try to formulate the problem now, so there could be, some inputs and there could be some outputs in a typical example we are discussing for a washing machine. So say, for example, the restriction should be the volume of the dirty clothes would be somewhere in between 0 to 2 cubic meter. Similarly, the weight of the dirty clothes could be a restriction. The type of fabric could be a restriction. Type of dirt, say, but here I have written none, but it could be a restriction. Maybe the washing machine is used by a particular group of people who are susceptible to a particular type of dirt, maybe farming, maybe painting or something. So there could be restriction from some and output based upon the need analysis and based upon your market survey. You could restrict it that the amount of date removed should be at least 97%. And the amount of shrinkage which happens in the clothes, that should not be more than 0.5%. And texturing, when it shrinks, the clothes should not appear, that the shrinkage should not be in the form of texture. So these all when we quantify things, this actually leads to the real problem formulation, and then you will start designing and thinking about the options, or I would say the different concepts which may be used to solve this problem and address this need in the market. When we go for concept hunt.
Sorry to interrupt, sir. Excuse
Yes.
me. Sir, the slides are not changing. Can you please change the slides as you go on with the topic?
1 minute, 1 minute.
Yes. Thank you, sir.
Let me share the screen, not the application. 1 minute. Are the slides changing? Am I audible?
Yes, sir, you're audible.
Slides are changing or not?
Yes, sir, now they are.
So this was the slide related to what I was discussing, the restrictions for a typical, designing of, say, for example, a new washing machine. And these were this was the slide I was discussing related to restrictions for input and output. So if we go for the next stage, which is the concept hunt. So there are three thumb rules, which is right attitude, acquire knowledge, and use knowledge. So when we talk about right attitude in a team who are doing, say, for example, who are solving a problem, or who are in a team of entrepreneurs, the right attitude is that a good idea can come from anybody, and no idea is a bad idea. And the right attitude also includes that more the number of ideas, the closer may we be to the optimal solution. So these three things, if we don't what we call premature evaluation. Say, for example, if a team involves 10 people and if somebody gives a vague idea or a vague concept, if we just evaluate that concept right at the brainstorming session, or right at the beginning when he starts expressing that idea, that will kill his creativity, and he will not speak. The next idea from his side may be the better idea. So that is the right attitude which a team should follow while doing concept hunt, or while doing brainstorming. So naturally, when a particular problem is that we are focusing on a particular problem, we have to acquire knowledge and related to that problem, read the basics related to that problem, and study the competitors, what we call sometimes as benchmarking, what are the existing products, how they are solving this problem. So that is part of acquiring knowledge. And then using that knowledge, we can use some aids of creativity. So creativity is again, we can aid creativity, but we cannot, we can enhance it. So, or trigger it by using different, concepts. One is brainstorming, and second is analogy. Analogy means, say, for example, we are discussing a problem, but there is some problem or some system which is analogous to it in some other industry or in some other system, a same problem is being solved, how they are solving that problem, that is basically using analogy. And inversion means if something reverse to it is being done somewhere, so can we reverse that system and use it here? Empathy is like you have to behave as if we are part of the system and how we would do it. And that actually helps in aiding creativity. So say, for example, you are doing something for farmers and you have never done farming, then maybe you will not be the right person to develop something for agricultural applications. Maybe you have to go to the field and start doing the same process, and then ideas may come out. And similarly, systematic search means, breaking the problem into smaller steps and thinking and ideating and brainstorming about not the whole problem, but maybe the different steps. So when we, 1 minute. So when we discuss about this creativity, we also use, apart from brainstorming, we adapt ideas from some analogous systems, or maybe a problem is similar to it is being used somewhere, and we magnify that and use it in our system. We use the concept of substitution, reversal, and rearrange, what I discussed in the previous slide also. So next step which we do in new product development is basically feasibility analysis. There may be n number of concepts. Apart from the performance or I would say the physical feasibility, we have to check other aspects which I have listed here. One is economic analysis. Second is financial feasibility, which is somewhat similar, and the social acceptability. So we do the CU test. So if a concept, is good from, say, for example, it does the job, but it is very costly. So it may not be good as an entrepreneur to use that concept. Or maybe there are some social norms against which the concept is going. So it may not be good to launch that product. So keeping that in view, we also do what we call break-even analysis. Sometimes we do that. What is the minimum number of, to make it simpler, we do the analysis. What is the minimum number of, products I may have to manufacture to, to be able to make a net profit. So that analysis is also necessary, because if you are making products, ultimately your job as an entrepreneur is to make money. So you should know what is the break-even point where I will cross, my input or my, input by way of finance and other things, and I will, be in a net profit. So another concept which is very important for entrepreneurs is the concept of concurrent engineering. Normally, when we talk about sequential engineering, what we do is that we do it in a very stepwise manner, and we follow step 1, then we go to step 2, then we go to step 3. If there is a problem at step 3, then we repeat the same. So because, say, for example, the person at step 3 identifies a problem, then again, we have to go to step 1. Say, as an example, I have used here, say, for example, we first design, then we manufacture, then we assemble, and then we, say, for example, send it to market. So while designing, there is no communication with the, say, for example, the end user. There is no communication with the person who is purchasing it or the person who is, doing the sales. So this actually makes the process as I would say, a monologous one, and it moves in one direction. So that makes it little bit redundant. And if some problem arises at a later stage, we lose time, we lose resources, and all the facets of a design or engineering, which may be cost, which may be aesthetics, which may be ease of, say, for example, manufacturing, ease of assembly, they do not get, imbibed in the design. So that is how the new concept of concurrent engineering, in which like we sit on a round table and each stakeholder actually can communicate with uh, all the stakeholders at the same time. And this helps us to make the problem simple, and I would say right from the ideation stage, the inputs from all stakeholders make the design process simple, as well as I would say the number of iterations needed because of the feedback in comparison to the sequential engineering is less in this concurrent engineering approach, and that actually shortens the product development life time, which is important in the in our times, because a lot of competition is there. The time by which you find an idea or a gap, some other person may also be working on the same problem, and he is out with the product before you. So that actually makes you to think about shortening this product design cycle. And concurrent engineering is an approach towards shortening the product development time. So the next step would be, if I have selected some idea or design, I would do prototyping. So prototyping actually helps us in a lot of things. Apart from communicating, we can predict performance, we could have a touch and feel of things, and it could be used as an aid in enhancing creativity. If you have a product in hand and you are asked to give solutions to different problems, parallel ideas, it could help you. So what we call design thinking, or maybe simplification, the compatibility of different assemblies, sub-assemblies can be checked by this prototyping. So if we just to sensitize or just to have an idea how this old design problem or the old design process is different from the new design process, let me give you an example. Say, for example, in our times, there was, say, for example, when people were communicating by telephone, so there was a evident need that there should be something which should be, wireless, so that people can carry it. So that means the need for a mobile phone or a wireless phone was evident, and everyone knew it, that there should be something after it which we could use, something which is wireless, and it could be mobile. People could talk and walk. And but after that, in our times, say, for example, internet was there, then people could communicate, people could email each other. Then there came some social networking sites, for that matter. Say, for example, Orkut was a very old social networking site in which people could, post, their comments and, ideas. But say, for example, then Facebook was I would say, refined version of, I would say, Orkut. But somebody may say, what was the need of Twitter? What was the need of, say, for example, Instagram? What was the need of other social networking sites? So the new design process or new, product development, modern need is being created. Now you may not sleep before checking your, status on WhatsApp, or maybe how many people liked you, what your friends have uploaded today. So a kind of need has been created in the market. So earlier the need was evident, and the designers or the entrepreneurs used to address that need. But nowadays, a kind of need is, the need is hidden, and sometimes you may have to create a need. So that is the difference, and that is the complexity in this new design process. So one more important aspect is that in old design process, the environment was known. A product was being, say, for example, manufactured in India, and we knew that it won't be used beyond the boundaries of India. But now you may manufacture a product here, it may be used in any corner of the world. You don't know what is the temperature there, what kind of behavior the end user is having. So you don't know the environment. So that makes the problem more complex. Little or no communication. Earlier, because of no global communication, no internet, no Facebook, no Twitter, there was no communication. But now a small tweet by a small customer could, crash your company in minutes. So that is the complexity, and that is the challenge of modern entrepreneurs, designers, and engineers. We have a very complex market. We have a very competitive market. Opportunities are huge, but challenges are also there. And earlier, if someone has seen an old tractor, and even after 20 years of research and R&D, we could see that no major improvement was done in the earlier designs. But now, if you see, after every 3 months, the design of the car changes. So because there is a lot of competition in the market, and you have to come up with new products, new refresh models. Maybe the changes are minor, but you have to keep on changing and improving. So that is what the design process and the new product development has become very, I would say, complex, very dynamic, and very challenging. So one more important aspect of this design or new product development is the biomimetics. So when we talk about biomimetics, it is actually aping nature. As we all know or believe that nature is the best designer. So if we could find some lessons from nature when we design something, that actually helps us to develop products which are, I would say, great products. So modern engineering is basically somewhere inspired by some natural system. So, and if we somehow try to, incorporate these natural systems in our design, that would be actually a very great thing. And I would introduce some, aspects of 3D printing, because now, earlier, the manufacturing of these complex shapes and structures was a challenge. But now, with the advent of this 3D printing, now developing complex shapes and structures has become very easy. And now taking lessons from nature is also easy. So what we are suggesting, these authors have shown in this diagram, that if we augment the 3D printing and biomimicry, we could take a lot of lessons from nature, and we could introduce a lot of I would say systems and subsystems, and improve the existing products by augmenting the science of 3D printing and biomimicry. So entrepreneurship, actually, what I understand is innovation driven, and what it should have is a short product development cycle. It needs capital. There's a huge risk, and it should involve less manpower. And actually, what entrepreneurship is about is bringing ideas to business. So when we think about these steps, and when I look at the recent technology of 3D printing, these all could be achieved by involving the concept of 3D printing in our designs and in entrepreneurship. So what startups or entrepreneurs need? They need less material usage, less labor costs, less initial investment, easy maintenance, part replacement and operation. And there is one concept which we call reverse engineering, or we may call it benchmarking also. So what we do is we examine competitive or prior products in detail by dissecting them and literally taking them apart and checking their structures, their functions, their operation, and knowing about the design, how does it work, why is the design like that. But what I see is that 3D printing can help with the issue of IPR, keeping that in mind, those legal issues. Earlier, it was difficult because we had a product in hand. We knew that there are no IPR issues, but we could not, develop a part like that. Now, there are 3D scanners which could actually develop, I would say the virtual data they could generate from the physical part, and they could print a physical part in hours. And that actually makes the reverse engineering process very simple. So let me give you a brief introduction of 3D printing. Earlier, when we talk about subtractive manufacturing, we had a block of material, and we used to develop a part out of it by doing machining or cutting the part in, and then we used to reach at a particular shape, like in case of, say, for example, carpentry. We do a lot of, we cut the material, a log of wood, then we achieve a particular shape. Say, for example, you had to create a chair out of wood. So there was a lot of material which got wasted, and we did it in a subtractive way. Now, this additive manufacturing is actually about, we have a CAD which is developed in a computer. I'm trying to make it simple because I know there are people from diverse fields. So when we have a virtual design in a computer, so we convert it into a different format which we call STL format, and then the 3D printing machine could develop the physical part out of that virtual design directly. So there is no material wastage. It can handle complex parts. The speed with which it does it is also remarkable and economical also. So in comparison to subtractive manufacturing, a lot of material wastage used to happen, but now since the additive manufacturing does it layer by layer, so there is no wastage or very little wastage which may be involved because of post-processing. So why we talk about this additive manufacturing in design or entrepreneurship? Because it gives us complexity for free. So there is no additional cost for complexity. Earlier in additive manufacturing, this subtractive manufacturing, we used to involve a lot of costs in maybe some, you have to design some intricate shapes, and a lot of cost used to go into that. But now the complexity is for free because the designing or the manufacturing is a layer by layer process. So types of 3D printing, I would just skip it because I don't feel. So the total cost of 3D printing, if we see, is also very less. If we see the supply chain costs, tooling cost, and production costs. So if we see in totality, the total cost per unit part is also very less in comparison to additive manufacturing. And a 3D printer could cost you just 15,000 or maybe less than 20,000 Indian currency, which is very less. And you could, as an entrepreneur, use this technology to bring new ideas to life without having, tools, without having a particular assembly line. And you could actually use this as a rapid prototyping tool to, touch and feel, to get a touch and feel of ideas. And as you see, this 3D printing involves, diverse, you talk of any application, you can use 3D printing in that. And rapid prototyping can be used in any application, because that can use plastic as a material. So if you are into jewelry, then a particular type of 3D printing machine needs to be invested into. But as far as the rapid prototyping part of it, you can use it in any application. And if we see the market scenario, by 2024, the 3D printing market size is expected to grow, hugely. And as far as area wise also, people are predicting that this field will, surge in the market. And the future is that, say, for example, you're in the evening or in the night, you feel that your bristles of the toothbrush are worn out. You give a command to your 3D printer, like a paper printer at home, and in the morning you have a new toothbrush and you brush your teeth by a new toothbrush. So this is the future, and I could see, I feel that entrepreneurs can use this technology in new design process, new product development process, and they can bring small ideas to life without much investment. I will discuss a small project with you so that you get an idea how 3D printing can be helpful in areas where even engineers used to, could not think about doing something. It's a work which was done by some students who were in an undergraduate course in our lab. So we know there are fractures, and we have heard about fractures. There are two common fractures which happen. Maybe some of us may have faced this in our early childhood or youth. So this Montiago fracture is very common, and we used to see that people used to, do plaster-based exoskeleton, which was non-water resistant, and it was very extremely heavy. It was cumbersome to carry. The issues of air ventilation, allergic skin reactions, and dullness of skin were there, and it caused irritation due to accumulation of sweat. So what we thought as a team, that this is the gap we will sort of address, and we will design a new exoskeleton bracket by using 3D printing. And this was actually the need. So then we did testing and evaluation by experts and doctors. So we designed a new exoskeletal bracket by using fused deposition modeling, which is a technique of 3D printing. And we could see that the new design we gave some holes for air ventilation, and it could avoid compartment syndrome due to less force on immobilized bone, and the mobility of proximal and dextral joints, which was not the case in case of plaster-based exoskeleton. And due to this lightweight, the range of motion of dextral joints also increased. Then we assessed our different designs, because we designed some 3 to 4 different designs. Then we assessed our designs on the basis of level of comfort, ease of joint movement, air circulation, muscle support, design, aesthetics, gripping, locking mechanism. And then we got input from different doctors and patients. And then this is one important example where we have to make decision making, because decision making is also very important aspect in entrepreneurship or in new design process, because you may have n number of ideas and you have to decide which idea is the best. So as an example, I will show you, say for example, here we have given level of comfort the weightage of 3, and ease of joint movement as the weightage of 4 on a scale of 5, say for example. Then based upon the inputs from different reviewers, we will make a Likert scale from, say for example, on a scale of 5. Then we will multiply this weightage by those responses. So that will actually help us to decide the best idea. So based upon this analysis, we could select a particular design and find the problem find the solution to the problem which was faced by the patients. So with this, I would end my presentation. I will say thank you. If there are any questions, I will be happy to take. I think I'm on time. There are 5 minutes left. If there are any questions, I'll be happy to answer. Jodh Sifat Kaur, I'm sorry, I could not, I cannot share the presentation, but anyways, this is, I think, being recorded. You can use that recording if that is to be used somewhere, if at all it is informative. Thank you for your, appreciation.
That was a very wonderful knowledge given by you, sir. And I really hope that our audience have learned many new things from this session. Questions that I personally need to ask. And I hope that would like to answer that.
Yeah. Can I suppose that there are no questions and I leave, or?
Sir. So I would know.
I'm sorry, you are not audible. You can type the question in the chat box. Could you please type the question in the chat box?
Excuse me, sir. I
Yes,
think there
yes.
is some technical issue at She's in, so just wait for a few minutes for her to join.
Okay. Do we have any questions? And so that could I know, shall I log out or wait?
Good evening, good afternoon, everyone. I, Sakshi Narayan, taking over the session as the host has some issue in her network, so she is not able to join the session. I, Sakshi Narayan, I thank on behalf of SEMS Welfare Foundation to Sir for imparting a wonderful knowledge with us and sharing a very effective and informative session on the development of the entrepreneurship. I hope audience has liked the session, and whatever the questions you have, please drop this question in the chat box, or you can contact us so that we can directly ask Sir to answer your questions, whichever is there. Sir, there is one question, if you may answer, if you allow us to answer or ask.
Yes, please, please.
Sir, as you discuss so many methods and tools that what are the required in the current scenario, do you think in upcoming days or in future, the concept of entrepreneurship is going to be changed?
Why it will change? What would be the reason?
Like now the more of these startup companies are coming up, instead of everyone is going to be an employee in under someone's head or in some other organization. So the number of organization of entrepreneurs or the startups are going to increase. So there can be any changes according to you? What
I cannot foresee that, but definitely because the market scenario will change if people, the number of entrepreneurs will increase, then maybe people define it in some other way. But I think the basic concept will remain the same. It may be reframed or it may be, somewhat refined, but the basic concept would be the same, and I don't see any changes in that. Like in science, the basic concepts remain the same, but people stand on the shoulders of giants and then, do iterative research. So similarly here also, it may be refined a bit, but the concept that entrepreneurship is about, startups are about, that will remain the same. But With the advent of new technology and particularly artificial intelligence and other tools, there is a challenge to every kind of industry. Things will change, but personally, I don't foresee a major change in this concept.
Thank you, sir, for clearing the doubts and clearing us the concept of the entrepreneurship among with us. I would like the audience to please switch on your camera for this screenshot. Thank you for this. So the feedback form will be shared in your chat box soon. And I, Sakshi Narayan, signing off for today's event. Thank you, audience, for joining us. Thank you, sir, for your precious time sharing your knowledge with us.
I thank you for giving me this opportunity, and I'd be happy to hear any constructive or I would say feedback from your side. Thank you. Have a good day.
Thank you, sir. Audience, please fill the feedback form. The feedback link will be available only for 6 hours.